Good afternoon. Today in math class, we are going to be going over our test to see how we did, see where we went wrong. Because some of us were feeling very confident about it and we made some mistakes, and we just want to understand where we went wrong. So let's look at our first objective for PO 46. Pizza. We all like pizza. Let's see how this should have worked out. So it says, what is the input if we have a membership fee to a pizza club is $10, then for $5 each month, you get a delicious pizza delivered right to your doorstep every week. So our input, what we're putting into our equation, that number we pick, is the month. So I put that as M, but it's your month. Then what we get out is going to be your cost. I put C. Now when we're going to write our equation relating the input to the output, we want to know the cost, because that's what we're getting out. So that's our Y. And that's going to have something to do with our M, that X input. We know we are multiplying it by $5 each month. And we have that $10 that we paid. So it's 5 times M plus 10. That is our equation that we have. So here's where some of us went a little bit off track. We were looking at putting in for the 3 months, 8 months, 15 months, and then 2 years. 2 years we know is 24 months. And there were quite a few of us that said, okay, 3 months times our $5, that's 15. We forgot that we have to add that 10. That's our equation. You always go back to your equation. So it should have been 25, 50, 85, and 130. Some of us remembered to add the 10 for the first few, and then we forgot to add the 10 for the last ones. So you always have to make sure that you are using the full equation every time. Any questions on those? All right, so let's look at the bottom one. It says you budgeted $285 for the pizza club. How many months of membership will that cover? Well, remember our equation was the cost equals $5 a month plus 10. We're going to use that same equation and put in the information that we know. Instead of knowing how many months, we know that final amount is $285, and we want to solve it for how many months. The first thing that we do is, instead of adding 10, we want to subtract 10, because we're going to want to get our M by itself. 10 minus 10 leaves us with just 5M. 285 minus 10 leaves us 275. Here we are multiplying by 5, so we want to divide each side by 5. So we're left with just months, and we get 55 months. Again, there were a lot of us that forgot that there was that plus 10. So you always go back to the original equation. Can't forget that. There were a lot of people who said 57 months because we forgot that we had a $10 membership fee. Any questions on that one? All right. Let's look at our Next objective. I can identify the domain and range of a relation. Ooh, there was quite a few. I got the first one and number 5 and number 7. We got a little confused. The domain, remember, is our x. So it's not 7 to -1, -1 to 7. It's just the x's listed in the table. So when we have our function table, it is just the x's that we have listed there. The range is just the y's. I had a lot of people saying, oh, 0 to 18. It's not 0 to 18. It's just what is in your function table. So it's very important that you remember when it's a function table, that's all that you write. On the flip side, over here, some of us were listing for our domain. We said -4, -3, -2, -1, 0, 1. Well, what about -3.5? Is that part of our segment? It is. What about a half? That's part of our segment. So you can't just list whole numbers because it's all of them. So you have to start at -4 all the way to 5. So it's all of those covered in there because it is that segment. It covers all of them. For the range, it would be from 2 up to 5. So when it's that segment, you have to make sure that you're including all of those numbers in there, not just the whole numbers. When it's a function table, it's just what is listed for the x and the y. Big difference between the two. A lot of us got confused by that. This one, because it's a line and we have those arrows, we know that the domain is all the real and the range is all the real numbers. How is a line different from a segment? A line includes all the real numbers. A segment is only certain numbers. I accepted a variety of answers in that, but you had to give me something along those lines, explaining the difference between the line and the segment. Any questions on those domains and ranges? People understanding why they got wrong what they got wrong? Okay. CO48. I can identify a function given a graph or relation. So we had to determine if it was a function, yes or no. Is it a function? So remember, for one x, there can only be one y. For this one, -3 is my x, has 2 different y's. So that is a no. For number 10, I have the same x of 5, has 2 different y's. So that is a no. For number 11, I do not have any repeated x's. So if it's not repeating any x's and giving it a different y, the answer is a yes. It's a function. And for number 12, there is not any repeated x's. So if there's not any repeated x's, it's a function. The only time it's not a function is if we have an x that has 2 y's assigned to it, or more. 2 or more y's assigned to it. Make sense? I can graph a function using a function table. Ooh, this one, a lot of people passed, but they got one wrong. So let's walk through and we're going to understand that rule for the table. Let's figure out how we did that. So let's graph it. -2, 1. 4, -2. 0, 0. And -4, 2. So it's going to look like that. Then it says, what's the rule for the table? Remember, before we took the test, I said, you can move them around so they're in order so you can see your pattern. So what I did was I put them in order. So I could try to find my pattern. So now that it's in order, I can kind of see how I go from my X to my Y. What were some patterns that people were seeing? How were you finding what the rule might be? I've got a lot of people that got this one right. What did you do, Izzy?
Well, I noticed that all the negatives that were in the x value became a positive, so I assumed you would have to multiply it by a negative because a negative times a negative is a positive.
Perfect. We had negative values in our X, but then positive in our Y. Or if we had a positive in the X, we had a negative in the Y. So that means we're going to be multiplying by a negative, because a negative times a positive will get us a negative. Okay, so we know that there's going to be a negative in there. What's another thing that we noticed, Sam?
It was always, the first number was always 1/4 time. So if you multiply it by 2, it was, the other number was 1/4 of it. I don't know how to explain that.
You mean the second number was the half of the first number?
Were you meaning 1/4 or were you meaning a half? Okay. So if we have 4, 2 is a half of 4.
Well, yeah, I didn't.
If we had 2, 1 is a half of 2.
Yeah, I don't know how I was trying to explain it.
Okay. But is that kind of what you were thinking?
Yeah.
4, we have 2 is a half of it. So we can see that we have half numbers. We're not going to be worried that this is small because it's a negative. We already understand our negatives. So when we set up our rule for our table, I'm not asking for a description. I'm asking for an actual rule like we did on our binder sheets. Some of us tried explaining what the rule is. We don't want an explanation. We want to actually see the rule. So, Finn, put your pencil down and pay attention, please. Are you on the correct page in your test? Okay. So, we know that there is a negative. We know that it's the y is half of our x. Some of us forgot that negative. Some of us didn't simplify. And so we came up with something else that means the same thing. We could say y equals negative x divided by 2. It's the same thing. I saw somebody do y equals 4x divided by negative 2. So 4x, well, actually, no, that one wouldn't work. 4x divided by negative 2, that's not what I saw, because that would just give me a negative 2x, and it has to be. We had a variety of things that if you didn't simplify it, I still accepted it. So it was, I think it was 2x divided by 4, maybe, negative 4. Trying to remember what I saw. It means the same thing. 2x divided by negative 4 would be 2x divided by negative 4, which is the same, simplified, same thing. Maddie,
I don't know what happened because I wrote the right like ordered pair.
Mhm.
So at some point I had to know the rule, but then
So-
I think I forgot it.
What it was you knew the patterns, so you could follow that pattern. -4, -2, 0, 4. Ooh, if I slid a 2 in here, this would be a -1. So some of us saw the pattern in the function table, and we got the right ordered pair that would be on that line, but we didn't know the rule for it. So that's why I wanted to walk us through this, because there were a lot of people that had a hard time figuring out the rule. Well, not a lot of people. There was enough people that struggled finding the rule that I wanted to point it out. So you can find the pattern. So I had a lot of people get 15 right because they could find the pattern. They just had a hard time with the rule. So the first thing we looked at was if there was a negative that we wanted to work with. Going from a negative to a positive or a positive to a negative tells us we're going to be multiplying or dividing by a negative. Second thing was seeing that we were having it each time. 2 to 1, 4 to 2, 4 to 2. So that's how we came up with the half. And then our question, will 8, 4 be on the line? Well, if we put an 8 in for x and we want negative half of it, half of 8 is 4, but it has to be a -4. So I even had some people say, no, but 8 -4 will.
I thought
You
it said
understood it.
-4, so I got that one. I thought it said 8 -4.
Oh, so you just read the problem wrong. Right? So we just have to be really careful when we're looking at it, because this is a +4, so we just have to slow ourselves down. Sometimes when we go too fast, we know the numbers we're looking for and we forget to look at that positive, negative signs. So that means taking the retake will be a whole lot easier. Any other questions on this objective? All right. It's always good to figure out where your mistake happened. So when we go back to do the practice work and the retake, we get it done nice and easy and we understand it. I can find the slope of a line that has been graphed, plot the ordered pairs, and find the slope of the line. So 1, 3, 2, 5. Our slope, rise, over, run. So we're going up 1, 2, over 1, -3, 0, +4, 2. So I'm going to go up 1, 2, and I'm going to go over 1, 2, 3, 4, 5, 6, 7. Some of us, because we had to go over so far, we counted wrong. Our run is going over 7, so it should be 2 7ths. So that one, I did have some people get wrong because they just counted wrong. So be careful, go slow. Here we have -4, -1, 0, 1. So we go up 1, 2. And we go over 1, 2, 3, 4. And we simplify. And it's a half. Now it says plot 2 ordered pairs with a slope of 3/2. I started right here at 0, 0. I went up 1, 2, 3 over 2. And there we go. Did you have to do it that way? No. I had a lot of different slopes of 3/2. Doesn't have to look just like mine. It just had to be 2 ordered pairs with a slope of 3/2. Any questions on the slopes? I think that one was a fairly good one for most of us. PO 51, I can find the slope of a line given two ordered pairs. This one, some of us forgot our formula. Some of us forgot that the y's go on top, the x's on the bottom. So you have to remember, y's on top, x on bottom. And if whatever you chose to be your 2's, whatever y was with the 2, the x has to be with the 2. So for number 21, I did 6 minus 3 over 9 minus 5, y2, y1, x2, x1, and I got 3/4. -5 minus 0, -9 minus -1. Some of us forgot how to work with our negative numbers, and we forgot how to subtract negatives. Well, -5 minus 0 keeps us at -5. -9 minus 1. When we're subtracting a negative, we're adding a positive. So -9 minus -1 is really -9 plus a +1, which is a -8. Negative over a negative gives me a +5/8. Here we have 3 minus 3 over -9 minus 7. 3 minus 3 is 0. I can stop myself right there. If I have a 0 as my numerator for a slope, my slope is a 0. X is going to be a straight line going horizontal. And then 3 minus -2 over 9 minus 6. Again, minus a negative, you're adding a positive. 3 plus 2 is 5. 9 minus 6 is 3. So I had a few friends who forgot that the y goes on top, x on bottom. We had them reversed. I had a few friends who forgot how to subtract negative numbers. So you know how you did on this objective, what you need to brush up on. Are there any questions on how I got those answers? We're feeling okay with it? We understand our mistakes? Then we have our reviews. So M6R8. First is simplifying our fractions. Some of us just had a little mess up on our math. 40 over 50, I can divide 5 out. 40 divided by 5 is 8. 45 divided by 5 is 9. Over here, I divided a 2 out. 18 divided by 2 is 9. 20 divided by 2 is 10. Can't go any simpler than that. Biggest factor they shared was a 2. What is 2/5 of 30? Of means multiply. So 2 times 30 is 60 divided by 5, and that gives me 12. Again, of means multiply, so 7 times 48. I didn't actually write down the number. 28. I think it's 346 divided by 8. Whatever 7 times 48 is, divided by 8 gives us 42.
There's 336.
I was close. 336. Thank you. Make sense? And actually, the way I did it in my head, now I'm remembering how I did it when I made the answer key. I simplified first. I did 48 divided by 8 was 6. 7 times 6 is 42. Here I did 5. 30 divided by 5 was 6. 2 times 6 is 12. So when I did my answer key, I did the shortcut way. The long way would be to multiply across and then divide. I divided first and then I multiplied. Any questions? All right, let's look at our last one. Solving the proportions. So I want to get my n to be on the top. So it's 25 times 12 divided by 30. So I multiply each side by 25. So those cancel out. And then I'm dividing it by 30. Dividing it by 30. And my answer is 10. Now you have 5 different cookie shapes and 3 frostings. How many frosted cookie combinations are there? Multiplying all of our possibilities gives us 15 cookie combinations. Given the numbers 1 to 15, what is the probability of randomly selecting an odd number? 1, 3, 5, 7, 9, 11, 13, 15. Out of those 15 numbers, 8 of them are odds out of 15. Some of us just left it as a fraction. Some of us divided 8 by 15 to get our percentage. I accepted either one because it didn't say what format it wanted the final answer in. So I accepted the fraction, I accepted the percentage. Consider 2 events, A and B. The probability of event A occurring is 3/4. The probability of event B occurring is 1/2. What is the compound probability of both events occurring? So we have 3/4 times 1/2. That gives me 3/8. My percentage would be 38%. Again, I accepted the fraction or the percentage. So all you have to do is multiply them together. Any questions on these review? Is it making sense? Any mistakes that we made? All right, a little girl goes to the store and buys 1 dozen eggs. 1 dozen is 12. As she is going home, all but 3 break. So 9 break. 3 do not. How many eggs are left unbroken? 3 do not.
I feel like no.
Maddie?
It's 12.
3.
I just said that.
Oh, sorry.
That's okay.
I said there's
All right. Any questions on the test? Obviously, with the extra credit, if you don't get it right the first time around, we don't get a second go at it. But with our objectives, remember at the back of our binder, we have the practice works. There's quite a few of us that I think want to do practice work on it. So for my friends at home listening to this, you will see your tests when you come back to school. So you will get your summary sheet when you come back. You will see where your mistakes happened and what you want to redo. For those of us in the classroom, we are going to work on practice work and answering any individual questions we have. So for my friends at home, we hope you are well and we hope to see you soon.